All right, welcome to the imaginary world of numbers. All your life you've been taught that the square root of a negative number does not exist. Well, in the real world it doesn't exist, but it does exist in the imaginary world. So here's kind of the explanation of what happens when we're solving a quadratic equation and we get the square root of a negative number. So not all quadratic equations have real number solutions. For example, a parabola that has no real solution would look like a graph with no x-intercepts. And we also know them as zeros, and we also know them as solutions. So think if you've ever seen a parabola that sits above the x-axis, that's what it would look like. It would have no real solutions because it doesn't cross the x-axis, right? So mathematicians created an expanded system of numbers that include the imaginary. So if it doesn't exist, let's just go ahead and make it up, right? The imaginary number square root of -1 indicated by the letter I. Called an iota. The imaginary unit can be used to write the square root of any negative number. For example, -25, the square root of -25 can be written as the square root of -1 times the square root of 25. So we know the square root of -1 and we know the square root of 25. The square root of 25 is 5, and the square root of -1 is I. So even though we would say there's no real solution for the square root of -25, there is an answer in imaginary number form. Let's look at number 2. It says the square root of -72. So we know we can write this as the square root of -1 times 72. Well, 72 is not a perfect square, so we can also write it this way. Square root of -1 times 36, that's a perfect square, times 2. So the square root of -1 is I, the square root of 36 is 6, and the square root of 2 stays inside. So that's how you would write that answer there. All right, square root of, or -5 times the square root of -9. Let's write this way, square root of 5 times the square root of -1 times 9. The square root of -1 is I, and the square root of 9 is 3. So we have -5 times 3I. In multiplication, you can treat I like a variable and multiply your numbers in front. So this becomes -15I. Pretty cool. A complex number, which is what these are, is written in standard form is a number a plus bi, where a and b are real numbers. The a is the real part and the number bi is the imaginary part. So we just learned about imaginary numbers I, and now what happens when we put them with real numbers, like what we did here, right? So powers of complex numbers, a little bit of a note here. Note that I squared is equal to the square root of -1 squared. And anytime you square a square root, it cancels. Therefore, I squared equals -1 and can follow any power after this. So let's look. I squared, we know, is the square root of -1 squared, which is -1. Okay, so I cubed is the same as me saying -1, or the square root of -1 cubed, which looks like this. The square root of -1 times -1 times -1, right? It's just multiplying it 3 times. Well, if I know that the square root of -1 squared is -1, I just have one more after that. So this is -1, and this is I. So it's -1i, or -i. Let's look at I to the fourth. I to the fourth can be written like this, -1 to the fourth power, the square root of -1 to the fourth power, which is also the square root of -1 times -1 times -1 times -1, right? Well, there's two of those, so I can write this as -1 squared times square root of -1 squared. Well, if this equals -1 and this equals -1, then -1 times -1 is just 1. Let me box this one up here. Hopefully I'm not blowing your mind too much. Let's look at the back. How do we do operations with complex numbers? So I have some examples for us. We're just going to do addition, subtraction, and multiplication. There is a division, but we have to rationalize the denominator, so I don't want to get in that over our notes here. So we have 8 minus I plus 5 plus 4i. So whenever you're adding or subtracting, you can just combine your like terms. You can treat that I like an X value in this case. So your like terms are -I and +4i, and 8 and 5. So 8 and 5 are 13, and -I and +4 are +3i. And so we want to write it like we want to write it in the form of A plus BI, which we've done here. All right, your turn. Try this. 9 minus I plus -6 plus 7i. Try that. All right, let's move over to subtraction. We have 7 minus 6i minus 3 minus 6i. So because it's addition here, we didn't have to change any of the signs, right? But when we're subtracting, remember that we got to distribute the negative, okay? Follows the same rules as when we're combining like terms. So we have -3 plus 6i. All right, now we can combine our like terms. So our like terms are -6i and +6i, and 7 and -3. So we have a 4, and those cancel, right? So our answer there is just, let me box this answer over here. Our answer here is just 4. All right, now you try. 3 plus 7i minus 8 minus 2i. Pause and try. All right, multiplication is the same idea, except we have a little bit of a loop because we're squaring things now. So let's try this multiplication together. If I have like a 4x on the outside, I'm going to distribute, right? So this is 4i times -6 plus 4i times i. So we'll multiply our numbers in front. So 4 and -6 is -24i. Think about that as like if it were an X value, right? And let's multiply these together. 4 and this is 1i. So we have 4i squared. Well, what is I squared? I squared is -1, right? So it's really 4 times -1. So we have -24i minus 4. And let's write this in standard form. So it's -4 minus 24i. Kind of cool. All right, let's try a foiling one. We're going to do this one together. 9 minus 2i times -4 plus 7i. So foiling first. So we're going to do 9 times -4 is -36. Outside, 9 times 7 is 63i. Inside, -2 and -4 is +8i. And last, we have -2i times +7i. So we have -14i squared. So keep in mind, remember, I squared is the same as -1. So we're going to do this in a couple of steps. We have -36 combine our like terms here, 63 and 8 is 71i. And then I have negative 14, but I know that it's equal to negative 1, right? We'll write it again. Negative 36 plus 71i plus 14. And now I have another set of like terms. So we have 36. Negative 36 plus 14 is negative 20. Oh my goodness. How about 22? Because I cannot do math apparently. Negative 22 plus 71i. And we wrote it in standard form. So the only difference in the multiplication is when you get to an I squared like this, then we have to replace it with a negative 1. Okay, we won't do division today, but please try these two up here on your own and bring those back to class.